So, well guys, good afternoon everyone. Okay. So, today in this session, I'm going to talk about here. So, one of the new chapter here, there is no states of matter, by the way. Okay. So, by the way, here we know basically. Okay, so listen here. So guys, since we have a chapter here, states of matter. So in that, that matter concept that here, what? So solid, liquid, and as well as here gas. Okay, and basically that here, I know that we already come across with that here solid state. Basically, you know that. Okay, and solutions that we also that completed concept with that here liquid state. Okay, and still we have right now. So states of matter concept with that here gaseous state. Okay, so gaseous state. So concern ಆಗಿರೋ ಒಂದು ಟಾಪಿಕ್ ಇದೆ ಈಗ that is states of matter. Okay, so ಈಗ NEET ಗೆ ನಿಮಗೆ ಇದು weightage ಎಷ್ಟು ಇರುತ್ತೆ ಅಂದ್ರೆ so average question is being what here few questions ಇರುತ್ತೆ. Okay, so NEET examination ಅಲ್ಲಿ so average question is being what here two questions have been arises so from this particular job. Okay, so let us go with the dear concept right now. Okay, so by the way, a very simple thing, matter. Okay, what is actually mean by matter? Anything which has mass and occupies space. Okay, so of course that. So let us start this particular chapter with some sort of interaction space. Okay, so which means that here we must have to know here some sort of intermolecular forces. Intermolecular forces. Okay, so look over here. So intermolecular forces, we have that here some many types here. Okay, very first thing, if you can see that here, London dispersion force, and second thing is that what? There is dipole interaction, Okay, and here dipole and induced dipole interaction. Dipole and induced dipole interaction. Okay, and here ion dipole interaction. So ion induced dipole interaction. Okay, so the last but not the least one, that is what here hydrogen bonding. Okay, so well guys, so before getting into these particular concepts, so we must know that here what is actually meant by intermolecular forces. Okay, here intermolecular forces is a kind of electrostatic force of attraction. Okay, is a kind of electrostatic force of attraction. Okay, so is being electrostatic force of attraction that has to be arises, that has to be existence only because of that here. When we could see that here two oppositely charged species are same kind of so the same, I mean that if you can see that, okay, unlike charges and as well as here like charges. What I mean is that here, okay, when actually this intermolecular force of attraction has been exist means, okay, so when that here attraction force that has to be exist between that here unlike charges and repulsion force that has to be exist between that here like charges, so those particular thing what we call is called as here intermolecular forces, and these intermolecular forces we have in these particular forms. One can be, I can say that London dispersion force, dipole interaction, dipole induced dipole interactions, ion dipole, ion induced, and the last but not the least, that is what here hydrogen bonding. Okay, so basically ನಾವು ಏನು ಹೇಳಿಕೊಂಡಿದ್ದೀವಿ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಏನಾಗಿರುತ್ತೆ ಬೇಸಿಕಲಿ ಅದು ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ಸ್ ಆಗಿರುತ್ತೆ. ಇದು ಹೇಗೆ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ಅಂದ್ರೆ ಎರಡು ಆಪೋಸಿಟ್ಲಿ ಚಾರ್ಜ್ ಸ್ಪೀಸೀಸ್ ನಡುವೆ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಅಂಡ್ ಎರಡು ಲೈಕ್ ಚಾರ್ಜಸ್ ನಡುವೆ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Okay, so ಇಷ್ಟು ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. Let us talk about that here very first. So let us go to that here London dispersion forces, what it actually means, and so where that particular force of attraction has been exist among the molecules. ಯಾವ ಥರದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳು ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಾ ಬರುತ್ತೆ Okay, so dispersion force and by the time let us talk about that now. Okay, very first let us move on to that here, the London dispersion forces. So London dispersion force here. So guys, that London dispersion force, you know what here is a kind of a weak attractive force. It's a weak attractive forces. Okay. So here the London dispersion force, you know what here, that is one of the weak attractive force basically. And one thing we must know that here, so London dispersion force that has to be exist in between that here, you know what, two non-polar molecules. Two non-polar molecules. How it could possible that here, so if a particular molecule is being non-polar, and how it could possible to get particular charge, so they are that particular molecules they over. And non-polar molecule ಆಗಿದೆ ಅಂದರೆ ಹೇಗಲ್ಲಿ ಒಂದು ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ಸ್ ನಾವು ನೋಡ್ತಾ ಹೋಗ್ತೀವಿ, ಹೇಗೆ ಸಾಧ್ಯ ಅದು? ಓಕೆ, ಡೈಪೋಲ್ ಇತ್ತು ಅಂತಾರೆ ಅಫ್ಕೋರ್ಸ್ ಚಾರ್ಜ್ ಸಪ್ರೇಷನ್ಸ್ ಇತ್ತು, ಮಾಲಿಕ್ಯುಲರ್ ಅಂತಾರೆ ಒಂದು ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ಈಗ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಾ ಇರೋದೇ ಒಂದು ನಾನ್ ಪೋಲಾರ್ ಮಾಲಿಕ್ಯುಲಲ್ಲಿ. ನಾನ್ ಪೋಲಾರ್ ಮಾಲಿಕ್ಯುಲ್ ಅಂತಾರೆ ನಮಗೆ ಅಲ್ಲಿ ಡೈಪೋಲ್ ಇರುತ್ತೆ, ಪೊಲಾರಿಟಿ ಇರುತ್ತಾ ಇಲ್ಲ, ಹೌದಾ? ಸೊ ಪೊಲಾರಿಟಿ ಇಲ್ಲದೆ ಹೋದರೆ ಸೊ ಅಲ್ಲಿ ಹೇಗೆ ನಮಗೆ ಒಂದು ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ? ಓಕೆ, ಸೊ ಬಟ್ ಆಗುತ್ತೆ ಆಫ್ಕೋರ್ಸ್. ಸೊ ಹೇಗೆ ಅಂತಂದರೆ ಜಸ್ಟ್ ಬಿಟ್ಕೊಳ್ತೀವಿ. ಓಕೆ, ಸೊ ಹಿಯರ್ ಲಂಡನ್ ಡಿಸ್ಪರ್ಷನ್ ಫೋರ್ಸ್ ಅಂತಾರೆ ದಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಎಕ್ಸಿಸ್ಟ್, ಓಕೆ, ಇನ್ ಬಿಟ್ವೀನ್ two non-polar molecules. In between two non-polar molecules. So you just let us consider here. So we would have two non-polar atom here. One can be here, I can take here A, and another is being here A. Okay, but the criteria is to be here. When these two particular non-polar molecules supposed to be, they are far away from one another means, so we could not see this kind of force of attraction. ಆ ದೂರ ಇತ್ತು ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಂತಂದರೆ ಅದು ಚಾನ್ಸ್ ಇಲ್ಲ, ಅಲ್ಲಿ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಲ್ಲ. ಬಟ್ ಯಾವಾಗ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ ಈಗ ಎರಡೂ ಪರ್ಟಿಕ್ಯುಲರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳೇನಾದರೂ ಸೊ ತುಂಬ ಕ್ಲೋಸ್ ಆಗುವ ಅಂತ ಅಂದರೆ ಆಗ ನಿಮಗೆ ಈ ಲಂಡನ್ ಡಿಸ್ಪರ್ಷನ್ ಫೋರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ಹೇಗೆ ಅಂತ ಅಂದರೆ, ಸೊ ಈಗ ಆಲ್ರೆಡಿ ಅದರಲ್ಲೂ ನಿಮಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂತ ಇದ್ದೇ ಇರತ್ತೆ, ಒಂದು ಯಾವುದೇ ಆಟಮ್ ತಗೊಂಡ್ರು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದೇ ಇರುತ್ತೆ. ಸೊ ಯಾವಾಗ ಅವು ಕ್ಲೋಸ್ ಆಗುತ್ತೆ ದೇ ಕ್ಯಾನ್ ಸೊ ಅಲ್ಲಿ ನಿಮಗೆ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಡಿಸ್ಟರ್ಬ್ ಆಗುತ್ತೆ. ಆ ಆಟಮ್ಸ್ ಸುತ್ತ ಇರುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಡಿಸ್ಟರ್ಬ್ ಆಗಿ ದೇ ವಿಲ್ ಗೆಟ್ ವಾಟ್ ಹಿಯರ್ ಅ ಟೆಂಪರರಿ ಡೈಪೋಲ್. ಓಕೆ, ಸೊ ಒಂದು ಟೆಂಪರರಿ ಡೈಪೋಲ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಅದಕ್ಕೆ. ಓಕೆ, ಸೊ ಇವಾಗ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಟಮ್ ಎರಡು ದೂರ ಇದೆ ಅಂದಾಗ ಲೆಟ್ ಅಸ್ ಮೇಕ್ ಟು ದೆಮ್ ಕ್ಲೋಸ್. ಓಕೆ, ಸೊ ದೇರ್ ಬೈ ವಾಟ್ ಆಕ್ಚುಲಿ ಹ್ಯಾಪನ್ ದಟ್ ದಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಹ್ಯಾಸ್ ಬೀನ್ ಡಿಸ್ಟರ್ಬ್. ಓಕೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ ಈಗ ಡಿಸ್ಟರ್ಬ್ ಆಗುತ್ತೆ. ಸೊ ದೇರ್ ಬೈ ದೇ ವುಡ್ ಗೆಟ್ ವಾಟ್ ಹಿಯರ್ ಸಾರ್ಟ್ ಆಫ್ ಅ ಡೈಪೋಲ್. Okay, so and in between those two particular molecules, a kind of a force that has to be exist, a intermolecular attraction has been exist. That is called as here London dispersion. Okay, so which is very simple here. What I mean is that so London dispersion force ಯಾವಾಗ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ಅಂದರೆ, ಸೊ ಯಾವಾಗ ಎರಡು ನಾನ್ ಪೋಲಾರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ತುಂಬ ಕ್ಲೋಸ್ ಆಗುತ್ತೋ ದೇರ್ ಬೈ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಹ್ಯಾಸ್ ಬೀನ್ ಡಿಸ್ಟರ್ಬ್ಡ್ ಅರೌಂಡ್ ದೇರ್, ದೇರ್ ಬೈ ಸೊ ಐ ಮೀನ್ ದಟ್ ಒಂದೊಂದು ಟೆಂಪರರಿ ಡೈಪೋಲ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Okay, and it's not a permanent, temporary dipole has been exist. So our particular time ಏನು force of attraction exist ಆಗುತ್ತಲ್ವಾ, that force of attraction what we call here London dispersion force. You can take any noble gases by the way. Okay, ಒಂದು ಆರ್ಗಾನ್ ಮಾಲಿಕ್ಯೂಲ್, ಒಂದು ಆರ್ಗಾನ್ ಆಟಮ್ ಇದೆ, ಇನ್ನೊಂದು ಆರ್ಗಾನ್ ಆಟಮ್ ಇದೆ, ಎರಡರ ನಡುವೆ ಕೂಡ ನಿಮಗೆ ಯಾವಾಗಲೂ ಒಂದು ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಯಾವುದು ಇರುತ್ತೆ, that is London dispersion force. Okay, so this is the thing, and most important thing is that what we have here. Okay, so that energy of the London dispersion force, it has a range, what here. Okay, so when force of attraction exists ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ಎನರ್ಜಿ ಎಷ್ಟು ರಿಲೀಸ್ ಆಗ್ಬೋದು, the energy of the London dispersion force, the energy of the London dispersion force is being what here, so 1 to 10 kilojoule per mole, 1 to 10 kilojoule per mole. This could be that what here, so that energy of the London dispersion force. Okay, and here so the thing is that so this particular London dispersion force that has to be depending on that here two major factors. So one can be here polarizability and geometry of the molecule. Polarizability and as well as the here geometry of the molecule. Okay, so ಈ particular London dispersion force ಎರಡು ಫ್ಯಾಕ್ಟರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ ಆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ನ ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಗಿ. ಒಂದು ಆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಥವಾ ಆಟಮ್ನ ಒಂದು ಪೋಲರೈಸಬಿಲಿಟಿ ಮೇಲೆ ಆ್ಯಂಡ್ ಅದರ ಜಿಯೋಮೆಟ್ರಿ ಮೇಲೆ ನಮಗೆ ಡಿಪೆಂಡ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಹಾಗಾದ್ರೆ ಈಗ ಇಲ್ಲಿ ನೋಡಿ, ಈಗ ಯೂಶುವಲ್ ಆಗಿ ಇಫ್ ಐ ಟೇಕ್ ದಟ್ ಹಿಯರ್, ಸಪೋಸ್ ವಿ ವುಡ್ ಹ್ಯಾವ್ ದಟ್ ಹಿಯರ್ ಹೆವಿಯರ್ ಆಟಮ್ ಅಥವಾ ಹೆವಿಯರ್ ಮಾಲಿಕ್ಯೂಲ್ ಇದೆ ಅಂತ ಅಂದರೆ ಅಲ್ಲಿ ಪೋಲರೈಸಬಿಲಿಟಿನೂ ಕೂಡ ತುಂಬ ಲಾರ್ಜ್ ಇರುತ್ತೆ. ವೇರ್ ವಿ ಕುಡ್ ಸಿ ದಟ್ ಹಿಯರ್ ಲಾರ್ಜ್ ಪೋಲರೈಸಬಿಲಿಟಿ, ದೇರ್ ಕುಡ್ ಬಿ ವಿ ಕ್ಯಾನ್ ಸಿ ದಟ್ ಹಿಯರ್ ಲಾರ್ಜ್ London dispersion force. ಓಕೆ ಅದೇ ಸ್ಮಾಲ್ ಆಟಮ್ ಅಥವಾ ಸೊ ಸ್ಮಾಲರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳಲ್ಲಿ ನಮಗೆ ಸೊ ದಟ್ ಪೋಲರೈಸಬಿಲಿಟಿ ಬೀಯಿಂಗ್ ವೆರಿ ಸ್ಮಾಲ್, ವೆರಿ low. Okay, so in that particular case we could see that here a small dispersion force is. It completely depending on that here, so that molecules polarizability and their corresponding geometry. So ಅದಕ್ಕೋಸ್ಕರ if you can compare here fluorine and as well as that iodine. ನೋಡಿ ಈಗ ಫ್ಲೋರಿನ್ ನಮಗೆ ಆಸ್ ಅ gaseous state ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ ಓನ್ಲಿ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಹಿಯರ್ ದಟ್ ಫ್ಲೋರಿನ್ ವಿಚ್ ಹ್ಯಾಸ್ ಸ್ಮಾಲ್ ಡಿಸ್ಪರ್ಷನ್ ಫೋರ್ಸ್. ಅಯೋಡಿನ್ ಈಗ ನಮಗೆ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ ಬಿಕಾಸ್ ಅದರ ಪೋಲರೈಸಬಿಲಿಟಿ ಜಾಸ್ತಿ ಇದೆ. ಓಕೆ, ಸೊ ಪೋಲರೈಸಬಿಲಿಟಿ ಜಾಸ್ತಿ ಇದೆ ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಲಂಡನ್ ಡಿಸ್ಪರ್ಷನ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದೆ. ದಟ್ಸ್ ವೈ ಅಯೋಡಿನ್ ದಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಎಕ್ಸಿಸ್ಟ್ ಇನ್ ದಟ್ ಸ್ಟೇಟ್ ಆಫ್ ಸಾಲಿಡ್ ಸ್ಟೇಟ್. Okay na, so here what we have to focus more means that where we have to focus more means, okay, so London dispersion force depend ಮಾಡ್ತಿರೋ ಎರಡು ಫ್ಯಾಕ್ಟರ್ ಇದೆ. So one is polarizability, ಇನ್ನೊಂದು geometry. Okay, so which means that suppose if we can take that here heavier or so or heavier molecule, so heavier molecules ali we could see that here large dispersion force, large polarizability, and so that you know what, large dispersion force, large dispersion force. So similarly we can say that so smaller atoms, small polarizability, okay, and small dispersion forces, small dispersion force. Okay, so here if you can see that there example that because of that particular fact here, so fluorine is, you know what, your gaseous state will exist as a, okay, and iodine that has to be existing that, you know what, this is solid state. Okay, so and here, so the London dispersion force basically, if you can see that here with respect to molecule, that London dispersion force always being, okay, proportional to that, you know what, here one particular factor that is, you know, so that London dispersion force always being proportional to that here, so 1 by, so 6th power of the R, 1 by 6th power of the R. Then what is here R stands for? So R is nothing but here the distance between that here two interactive species. Okay, so a distance between the two particular non-polar molecules, non-polar atoms. Okay, that we can say that here R is here. Okay, R can be, you know what, here the distance between two interactive particles. Okay, so the London dispersion force always is proportional to, you know what, so 1 by 6th power of the orbits. Okay, so where R can be stands for that, you know what, the distance between the here two interactive particles, or we can say that here two non-polar molecules. Okay, and most important thing is that here London dispersion force that has to be increases. So with respect to here weight, with respect to surface area, okay, with respect to that electrons which is present in the given so molecule. So weight ಮೇಲೆ ಡಿಪೆಂಡ್ ಮಾಡ್ತಾ ಇದೆ, ಸರ್ಫೇಸ್ ಏರಿಯಾ ಮೇಲೆ ಡಿಪೆಂಡ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ, ಆ್ಯಂಡ್ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಸೈಜ್ ಮೇಲೂ ಕೂಡ ಡಿಪೆಂಡ್ ಮಾಡುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ಹಿಯರ್ ದ ಲಂಡನ್ dispersion force that has to be depending on that here majorly 4 factors basically. Okay, so London dispersion force basically that has to be increases, which has to be increases weight of the particular species, and here size, and as well as here surface area, and so number of electrons. So London dispersion force that has to be increases guys. ಅಂದ್ರೆ ಆ ಎಕ್ಸ್ಟೆಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ನಾವು ನೋಡ್ತಾ ಹೋಗ್ತಾ ಇದೀವಿ ಅಂತಾರೆ, ಆ ಫ್ಯಾಕ್ಟರ್ ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಮಾಡುತ್ತೆ, ಸೊ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ನಾನ್ ಪೋಲಾರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ನ ವೆಯ್ಟ್ ಮೇಲೆ, ಓಕೆನಾ, ಮೀನ್ಸ್ ಅದ್ರ ಮಾಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸೊ ಆ್ಯಂಡ್ ಸೈಜ್, ಓಕೆ, ಆ್ಯಂಡ್ ದೇರ್ ಸರ್ಫೇಸ್ ಏರಿಯಾ, ಆ್ಯಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ದೇರ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಸೊ ಈ 4 ಫ್ಯಾಕ್ಟರ್ಗಳ ಮೇಲೆ ದಟ್ ಎಕ್ಸ್ಟೆಂಟ್ ಆಫ್ ಡಿಸ್ಪರ್ಷನ್ ಫೋರ್ಸ್ ವಿ ಕುಡ್ ಈಸಿಲಿ ಮೆಜರ್ ದಿಸ್. ಓಕೆ, so guys, this is all about here, you know what, that London dispersion force we must know here. Okay, so this is one of the kind of intermolecular forces that has to be existing between the two non-polar molecules. ಎರಡು ನಾನ್-ಪೋಲಾರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳ ನಡುವೆ ಯಾವಾಗಲೂ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ, ಬಟ್ ಆ ಎರಡೂ ನಾನ್-ಪೋಲಾರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳು ಕ್ಲೋಸ್ ಆಗಬೇಕು ಮಾತ್ರ. ದಟ್ ಇಸ್ ದ ಕ್ರೈಟೀರಿಯಾ, ದಟ್ ಇಸ್ ದ ಮಸ್ಟ್ ಕಂಡೀಷನ್. Okay, so if they are far away from one another, so we could not see that Okay, so this particular London dispersion force among the molecules. Okay, so this is we must know, and that here one particular factor we must know here, that London dispersion force always being proportional to the here 1 by 6th power of the R, where R can be stands for the distance between the here two non-polar molecules. Okay, so this is all about that here London dispersion force. So next one we'll move on that here. So dipole interactions. So let's go with that particular. So force is. Dipole interaction. So guys, dipole interactions, the name itself indicating the rover. Okay, that particular force of interaction that has to be existing between the two polar molecules. Okay, so here non-polar molecules that exist agodu London dispersion force. ಈಗ dipole interactions exist ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಎರಡು polar molecules ಗಳು ಇರಲೇಬೇಕಾಗುತ್ತೆ. Okay, and ಆ ಎರಡು molecules ಗಳು ಕೂಡ closed ಆಗಿದೆ. Okay, they have to be very close to each other. So here, the dipole interaction basically that has to be exist is between two polar molecules. Okay, then only that here a kind of an interaction has been exist among the species. Okay, so and if you can see that the energy of the dipole interaction that has to be range which has as London dispersion force had no, so that is 1 to 10 kilojoule per mole. But here dipole interaction which also that here, so some kind of energy ranges here. Okay, the energy range of so dipole interaction is being what? Dipole interaction is being so 3 to 4 kilojoule per mole. So 3 to 4 kilojoule per mole. Okay, so here if you can see that dipole interactions means that suppose if I have that here one polar molecule, that is a very best example is that here HCl. Okay, so if you can see that here, so since that chlorine which has the here most electronegative element as compared to hydrogen, that's why the chlorine that would attract some sort of a electron density from the here hydrogen, that's why it would has that, it would give a charge delta minus, and whereas that H which has delta plus. Okay, a permanent dipole has been exist here over. Okay, the same kind of a scenario we can see that another particular HCl molecule where chlorine which has delta minus, H which has delta plus. Okay, in between these two particular polar molecules, we could see that here. So one, a force of attraction is a kind of a force of attraction that has to exist now. That what we call here, that is dipole interactions. Okay, very simple thing. So dipole interactions ಆಗಬೇಕು ಅಂತಂದ್ರೆ so ಇದು non-polar polar molecules ಇರಬೇಕು. ಆ polar molecules ಗಳ ನಡುವೆ ನಮಗೆ ಏನಾಗುತ್ತೆ? So ಒಂದು interactions ಆಗುತ್ತೆ. So minus plus. Okay, so this kind of a force of attraction what we call here dipole interactions. Dipole interactions. So here, suppose ಈ dipole interactions their extent ಯಾವ ಥರದ ಸ್ಪೀಷೀಸ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಂದ್ರೆ ಸಪೋಸ್ ಈಗ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಂತ ಅಂತಂದ್ರೆ ಎಲ್ಲಾ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗೂ ಪೊಲಾರಿಟಿ ಸೇಮ್ ಇರುತ್ತಾ? ಒಂದೊಂದು ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗೆ ಪೊಲಾರಿಟಿ ಒಂದೊಂದು ಥರ ಇರುತ್ತೆ. ಈಗ ಇಲ್ಲಿ ಕೇಸ್ ಬಂದು ಏನಿದೆ ಅಂತ ಅಂದ್ರೆ ದಟ್ ಎಕ್ಸ್ಟೆಂಟ್ ಆಫ್ dipole interaction has been depending on that here. Okay, the molecule which has to be more polar. Okay, ಇವಾಗ ಮಾಲಿಕ್ಯೂಲ್ ಅಂದ್ರೆ ಮೋರ್ ಪೊಲಾರಿಟಿ ಎಕ್ಸಿಸ್ಟ್ ಮಾಡ್ತಿತ್ತು ಅಂತ ಅಂದ್ರೆ ಅಂಥ ಪರ್ಟಿಕ್ಯುಲರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳಲ್ಲಿ dipole interactions ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರುತ್ತೆ. ಅರ್ಥಾಗ್ತಿಲ್ವಾ? So the dipole interaction, suppose let us write here in this particular form, if molecule is more polar, then dipole interaction is also more less. And you can see that here. Okay, so this particular dipole interaction that has to be varies with that here state of a species case. ಅಂದರೆ ಇವಾಗ ಅಂದರೆ ವಿಚ್ ಮೀನ್ಸ್ ದಟ್ ಹಿಯರ್ ಈಗ ಸಾಲಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳಲ್ಲೇ ನಿಮಗೆ ಡೈಪೋಲ್ ಡೈಪೋಲ್ ಇಂಟ್ರಾಕ್ಷನ್ಸ್ ರೇಂಜ್ ಒಂಥರ ಇರುತ್ತೆ ಆ್ಯಂಡ್ ರೊಟೇಟಿಂಗ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳಲ್ಲೂ ಕೂಡ ಡಿಫ್ರೆಂಟ್ ಫಾರ್ಮ್ಸಲ್ಲಿ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಈಗ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಸಾಲಿಡ್, ಓಕೆ, ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಸಾಲಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳಲ್ಲಿ, ಸೊ ಸಾಲಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳಲ್ಲಿ ದಟ್ ಇಂಟ್ರಾಕ್ಷನ್ ಇಸ್ ದೇರ್ ನೋ ಡೈಪೋಲ್ ಡೈಪೋಲ್ ಇಂಟ್ರಾಕ್ಷನ್. Dipole dipole interaction is proportional to 1 by q of the r, 1 by q of the r, where r we know that here distance between that here two polar molecules. Okay, this is with respect to here solid molecules. Okay, so dipole dipole interaction is proportional to here 1 by r cube. Okay, but in the case of rotating molecule, case of rotating molecule, we can see that okay, that dipole dipole interaction is proportional to 1 by 6th power of the r, 1 by 6th power of the r. Okay, so here we must know these two particular things here. So 1 by r cube, that would be only that restricted to that here solid molecules. But in the case of rotating molecules, we can see that here that dipole-dipole interactions, which has been proportional to that here 1 by 6th power of the r. So where are we know that distance between that here two polar molecules. Okay, so this is the the thing we must know in between. So with respect to the dipole-dipole interactions, ಇಲ್ಲಿ ಅಷ್ಟೇ ಇದು ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಅಲ್ಲಿ ಏನೆಲ್ಲ ಕ್ರೈಟೀರಿಯಾ ಫಾಲೋ ಮಾಡಬೇಕು ಅಷ್ಟು ಫೋಕಸ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸಾಕು. ಸೊ ಇದರಲ್ಲಿ ಅಷ್ಟೇ ಬೇಕಾಗಿರೋದು. ಓಕೆ, ಸೊ ಪ್ಲೀಸ್ ಟು know that so focus on these particular concepts. So next we'll go to the here. So dipole and induced dipole interactions. Okay, which is also most interesting thing right now. Okay, please we focus. So dipole and induced dipole interactions. So dipole and induced dipole interactions means, so these kind of interaction that has to be exist in between that here polar and non-polar molecules. Okay, one kade completely to non-polar molecules, so one kade completely to polar molecules. ಈಗ ಒಂದು polar molecules ಈಗ ಒಂದು non-polar molecules. ಒಂದು polar molecule non-polar molecule ನಡುವೆ ಒಂದು force of attraction exist ಆಗುತ್ತೆ. That force of attraction called them is dipole and induced dipole interactions. ಅರ್ಥ ಕ್ಲಿಯರಾ? So this thing is that this particular interaction has been exist between so polar and non-polar molecules. So polar and as well as the here non-polar molecules. So you just see that here. So polar and non-polar molecule. So I must take right now. So polar molecule, suppose. Okay. So one best example anta andre so HCl and as well as the chlorine. HCl and as well as the chlorine molecule has been there. Okay, in between these two particular molecule, so a kind of a force of interaction has been exist. So that we can call it as here, that is dipole and induced dipole interactions. Okay, so since we know that here HCl molecule which has that here permanent dipole, where chlorine molecule that is one of the neutral species, it doesn't have any kind of a charge right now. But definitely ಅದರಲ್ಲೂ ಚಾರ್ಜ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಯಾವಾಗ ಅಂತ ಅಂದರೆ ಈ HCl ಆಲ್ರೆಡಿ ಡೈಪೋಲ್ ಹೊಂದಿದೆ. ಸೊ ಈ HCl ಮಾಲಿಕ್ಯೂಲ್ ಇಂಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ ನೀವು ಚಾರ್ಜ್ ಪಡ್ಕೊ ಅಂತ. ಓಕೆ, ಯಾವಾಗ ಕ್ಲೋರಿನ್ ಮಾಲಿಕ್ಯೂಲ್ ಸಪೋಸ್ ಟು ಬಿ ಏನಾದರೂ ನಿಯರ್ ಆಯಿತು HClಗೆ ಅಂತ ಅಂದರೆ ಆ ಕ್ಲೋರಿನ್ ಸುತ್ತ ಇರುವಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿನ ಈ HCl ಮಾಲಿಕ್ಯೂಲ್ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಿಬಿಡುತ್ತೆ. ದೇರ್ ಬೈ ಅದರ ಒಂದು ಕ್ಲೋರಿನ್ ಪಾರ್ಷಿಯಲ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಸೊ ತಗೊಳುತ್ತೆ, ಇನ್ನೊಂದು ಕ್ಲೋರಿನ್ ಪಾರ್ಷಿಯಲ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ನ ಸೊ ಬಿಯರ್ ಮಾಡುತ್ತೆ. ದೇರ್ ಬೈ ಒಂದು ಎರಡು ಅಪೋಸಿಟ್ಲಿ ಚಾರ್ಜ್ ಸ್ಪೀಷೀಸ್ ಅಲ್ಲೂ ಒಂದು ಇಂಟ್ರಾಕ್ಷನ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ದ್ಯಾಟ್ ಇಂಟ್ರಾಕ್ಷನ್ ವಾಟ್ ವಿ ಕಾಲ್ ಹಿಯರ್ ಡೈಪೋಲ್ ಇಂಡ್ಯೂಸ್ಡ್ ಡೈಪೋಲ್ ಇಂಟ್ರಾಕ್ಷನ್ಸ್. Okay, so you just have patience to get this particular thing, guys. So please, okay. So your HCl molecule has been there, which has partial positive and which has partial negative here. Okay, and your chlorine molecule has been there over. So basically, it doesn't have any kind of charge around it. Okay, so ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಏನು ಕ್ಲೋರಿನ್ ಸುತ್ತ ಇದೆ ಅಲ್ವಾ, ಇದು ಯಾವಾಗ ಮಾಲಿಕ್ಯೂಲ್ ನಿಯರ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಈ HCl ಮಾಲಿಕ್ಯೂಲ್ ಅದರ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿನ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಿಬಿಡುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಿಬಿಡುತ್ತೆ. ಸೊ ದೇರ್ ಬೈ ಅದರಲ್ಲಿ ಒಂದು ಕ್ಲೋರಿನ್ ಇದೆ, ಸೊ ಪಾರ್ಷಿಯಲ್ ಪಾಸಿಟಿವ್ ಪಾರ್ಷಿಯಲ್ ನೆಗೆಟಿವ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಓಕೆ, ಸೊ ಇದು ನಿಮಗೆ ಪರ್ಮನೆಂಟ್ ಅಲ್ಲ, ಇದು ಕೂಡ ಟೆಂಪರರಿನೇ. But here already HCl molecule which has what here permanent dipoles. Okay, so thereby here what ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ actually electronegativity difference we could see 0. Electronegativity difference in the chlorine molecule of course 0 ಇದೆ ಅಲ್ವಾ. So that is example for that here pure covalent species. Okay, so ಹಾಗಾಗಿ ಇವಾಗ ಈ particular case ಅಲ್ಲಿ ನಮಗೆ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ. Okay, so HCl and as well as that here, so chlorine molecules ಇರೋದ್ರಿಂದ, so in this particular case a force of interaction has been exist. Okay, that force of interaction what we call here. See, well guys, okay, so dipole, so dipole induced dipole interactions is being there here. Okay, so this kind of interaction that has to be exist in between that here. So one can be polar and as well as that non-polar molecules. Okay, here HCl has been there and chlorine which has been there. Okay, HCl is being polar and so chlorine molecule is non-polar molecule. Okay, in between these two particular species, so a kind of interaction has been exist. That what we call here dipole induced dipole interaction. Okay, basically chlorine ಮೇಲೆ ಹೇಗೆ charge exist ಆಗ್ತಿದೆ ಅಂತ ಅಂದ್ರೆ, so that HCl molecule is being a polar molecule. Okay, so there we can see that here charge separation already. Okay, this molecule that has to be disturbed the here electron cloud which is present around the here chlorine molecule. So thereby that chlorine molecule which has also sort of a charge, so for a time being it has a charge, so delta plus and delta minus. Okay, so in between these two oppositely charged species a force of interaction has been exist, that we can call it as a here dipole and induced dipole interaction. And if you can see that here, so this dipole induced dipole interaction which has been proportional to that. Okay, so dipole and induced dipole. Dipole and induced dipole that has to be proportional to that here. So 1 by square of the r. 1 by square of the r, where of course r is nothing but here what distance between that here. So polar and non-polar molecules. Okay. So this we must know that here. Okay, dipole induced dipole interactions. So next we'll move on to that here. What here ion and as well as that here dipole interaction. Ion dipole interaction which is also really most important. Ion dipole interaction, basically ion dipole interactions ಅಂತಂದ್ರೆ ನೀವು ಹೇಳ್ಬೋದು ಈಗ ion ಇರುತ್ತೆ ಅಂದ್ರೆ ಒಂದು ionic species ಇರುತ್ತೆ. Okay, of course ಒಂದು polar molecules ಇರುತ್ತೆ. Okay, ಇವಾಗ we have right now what here aqueous solution of sodium chloride. Aqueous solution of sodium chloride is the best example for that here ion dipole interactions. Ion dipole interactions. So ಹೇಗಾಗುತ್ತೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೇಸಲ್ಲಿ ಹೆಂಗೆ ಆ ಥರದ ಇಂಟ್ರಾಕ್ಷನ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಇಟ್ ಇಸ್ ನಾವು ಗೊತ್ತಾಯ್ತು. So ion dipole interactions. So ion dipole interaction, of course, that particular interaction has been exist in between ion and so dipolar molecule. For dipole molecule, or we can say that here polar molecule. Okay, so we can say that here polar. Okay, so here you could see that okay ion dipole interactions antadre, suppose if I take that okay, so sodium chloride in water, then we will see that here that ion dipole interactions. Yes, by the way water is polar molecule. Okay, so and if you can see that Na plus, okay, so in aqueous solution of sodium chloride scenarios must be so something like that. Okay, where oxygen which has partially the kind of interaction has been exist among species. Okay, so this particular interaction what we call here, so ion dipole interactions. Ion dipole interaction. Andre ಈಗ ಒಂದು cat and Na plus and as well as water molecules ನಡುವೆ ಆಗುವಂತ interaction. ಅಥವಾ you can take that here Cl minus So Cl minus, that is chlorine ion has been there now. Okay, and the hydrogen क्या charge होते हैं partial positive. So thereby, what actually happened there over. Okay, so this kind of interaction has been existed over. So this could be example for the here ion dipole interactions. ಅಂದರೆ ಇದು ಯಾವುದೇ ಒಂದು particular aqueous I mean that so solution of salt ತಗೊಂಡ್ರು ಕೂಡ but ಆ salt polar salt ಆಗಿದೆ basically so like KCl like this. Okay, so ಆ form ಅಲ್ಲಿ ಆ ತರ ಒಂದು example ತಗೊಂಡ್ರೆ ಅಂದರೆ of course that ion dipole interaction you can see in those particular set of combinations. Okay. So well guys, so this is all about here ion dipole interaction basically, and one thing you must know that ion dipole interaction here itself that has to be depending on that. Okay, so that can be that ion dipole interaction I need the represent ಮಾಡ್ಕೊಳ್ತೀವಿ. Okay, so that ion dipole interaction has been depending on that oxidation state. I mean the charge on the particular ions things. Charge on the particular ion that can be indicated by here Z, and their corresponding dipole moment. Dipole moment. Okay, and here which also depending on that here, so square inverse of the R case. Okay, so square inverse of the R, where R can be what here distance between the here ion and as well as the here polar molecules. Okay, so here E mu divided by here R square andre that ion dipole interaction has been depending on that here Z, that charge on the ion, where mu is being what dipole moment. Okay, where R is distance between the species, distance between the species. So you must know that so ion dipole interaction is right now. So let us go with it here. Another one where you can see that. Okay. So ion induced dipole interactions. Ion and as well as that induced dipole interaction. Ion induced dipole. Induced dipole interaction. Okay, so the thing is that so in this particular case ion induced dipole interaction means so this kind of interaction has been exist in between what, okay, ion and as well as the here non-polar molecules, ion and as well as the here non-polar molecules. Okay, so best example I would give here. Okay, this kind of interaction we can see in between iodine and as well as the NO3 minus. Iodine and as well as the NO3 minus, where NO3 minus is being here ion, of course we know, and iodine is best example for the here non-polar molecule. So in between those two particular species are there, we can see that here. So ion induced dipole interactions. Okay, this is the information saga. And so we have at last that last but not the least hydrogen bonding. Okay, so the hydrogen bonding. Okay, so what is actually mean by hydrogen bonding? Hydrogen bond means okay, the bond that has to be exist between the here hydrogen and most electronegative elements. Okay, that we can say that here hydrogen bond basically. Okay, so of course, so that hydrogen bonding that has to be exist in between hydrogen and most electronegative element. Okay, example we can see that here. So HF. Okay, so HCl we can see that. Okay, and so what H you put out we can see that. OH we can give. NH we can also give. Okay, so we have many examples basically. Okay, so the strength of the hydrogen bonding will depend on the strength of the hydrogen bonding that has to be depending on that here the difference between the electronegativity difference between hydrogen and as well as the here electronegative species. Okay, a difference in just ಇದೆ ಅಂತಂದ್ರೆ of course that okay, so that hydrogen bonding is being that strength of the hydrogen bonding is being more ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ. ಓಕೆ, ಅಂದ್ರೆ ನಮಗೆ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಡಿಫ್ರೆನ್ಸ್ ಜಾಸ್ತಿ ಇರಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಆ ಸ್ಪೀಷೀಸ್ ಅಲ್ಲಿ ಓಕೆ ಯಾವುದರಲ್ಲಿ ಆ ಡಿಫ್ರೆನ್ಸ್ ನಮಗೆ ಜಾಸ್ತಿ ಬರುತ್ತೆ ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ, ಸೊ ಅಲ್ಲಿ ನಿಮಗೆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಸ್ಟ್ರೆಂತ್ ಗೊತ್ತಾಗ್ತಾ ಹೋಗುತ್ತೆ. Okay. So here the strength of the hydrogen bonding, is depending on your depends on the difference between the electronegativity difference between hydrogen and electronegative species. Electronegativity. Okay. So this we must know here. So guys, this is all about what here, that intermolecular force of attraction. So this is all that all these form of an intermolecular force of attraction, where we can see that, where we say that intermolecular force of attraction is a kind of electrostatic force of attraction. Now exist between that here. So attraction has been expressed between two unlike charges, and repulsion force has been expressed between here two like charges. Okay, so half of our exist molecular that interactions okay. So ಹಾಗಾದ್ರೆ ಈಗ ಎರಡು ಪರ್ಟಿಕ್ಯುಲರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಸೊ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದು. ಒನ್ ಕ್ಯಾನ್ ಬಿ ಹಿಯರ್ ಸೊ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಅಂಡ್ ಥರ್ಮಲ್ ಎನರ್ಜಿ. ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಹಿಯರ್ ಥರ್ಮಲ್ ಎನರ್ಜಿ. ಅಂದರೆ ದ ಥಿಂಗ್ ಈಸ್ ದಟ್ ಈಗ ನಾವು ನೇಚರಲ್ಲಿ ಒಂದಷ್ಟು ಸಬ್ಸ್ಟೆನ್ಸ್ನ ಆಸ್ ಅ ಸಾಲಿಡ್ ಫಾರ್ಮಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀವಿ, ಆಸ್ ಅ ಲಿಕ್ವಿಡ್ ಫಾರ್ಮಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀವಿ, ಆಸ್ ಅ ಗೇಷಿಯಸ್ ಫಾರ್ಮಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀವಿ ಅಂತ ಅಂದರೆ ಸೊ ಅದಕ್ಕೆ ರೀಸನ್ ಯಾರು ಬೇಸಿಕಲಿ ಓಕೆ ಯಾವ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಅಲ್ಲಿ ಆ್ಯಕ್ಟ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ಎಸ್ ಇವಾಗ ನಾವು ಕಲ್ಲನ್ನ ಇವಾಗ ಸಾಲಿಡ್ ಸ್ಟೇಟಲ್ಲಿ ನೋಡ್ತೀವಿ, ವಾಟರ್ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟಲ್ಲಿ ನೋಡ್ತೀವಿ, ಗ್ಯಾಸಸ್ ಗೇಷಿಯಸ್ ಸ್ಟೇಟಲ್ಲಿ ನಾವು ನೋಡ್ತಾ ಹೋಗ್ತೀವಿ. ಅಂದರೆ ಯಾಕೆ ಇವಾಗ ಒಂದು ಯೋಚನೆ ಮಾಡ್ಕೊಳ್ಳಿ, ಯಾಕೆಲ್ಲ ಸ್ಪೀಷೀಸ್ ಒಂದೇ ಸ್ಟೇಟಲ್ಲಿ ಇಲ್ಲ, ಯಾಕೆಲ್ಲರೂ ಲಿಕ್ವಿಡಲ್ಲೇ ಇಲ್ಲ, ಯಾಕೆಲ್ಲರೂ ಸಾಲಿಡ್ ಸ್ಟೇಟಲ್ಲೇ ಇಲ್ಲ, ಯಾಕೆಲ್ಲರೂ ಗೇಷಿಯಸ್ ಸ್ಟೇಟಲ್ಲೇ ಇಲ್ಲ, ಯಾಕೆ ವಿ ಕುಡ್ ಸಿ ದಟ್ ದೇ ಆರ್ ಡಿಫ್ರೆಂಟ್ ಫಾರ್ಮ್ ಆಫ್. ಸೊ ಯಾಕೆಂದರೆ ಬಿಕಾಸ್ ದೇರ್ ನೋ ದಟ್ ಇನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸಿನಾರಿಯೋ ದೇರ್ ವಿಲ್ ಬಿ ಟೂ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಹ್ಯಾಸ್ ಬಿನ್ ಆಕ್ಟಿವ್. One can be so intermolecular force of attraction and thermal energy. ಹಾಗಾದ್ರೆ ಈಗ ಈ ಎರಡು ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಯಾವ ಪರ್ಟಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಡಾಮಿನೇಟ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೋ ಸೊ ಅಲ್ಲಿ ಆ ಮಾಲಿಕ್ಯುಲರ್ ಸ್ಪೀಶೀಸ್ ಅದರ ಫಿಸಿಕಲ್ ಸ್ಟೇಟ್ನ ಚೇಂಜ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆನಾ? ಹಾಗಾದ್ರೆ ಬನ್ನಿ ಈಗ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಅಂತ ತಗೊಳ್ಳೋಣ, ಥರ್ಮಲ್ ಎನರ್ಜಿ. ಈಗ ಏನಾದರೂ ಕೂಡ ಸೊ ಥರ್ಮಲ್ ಎನರ್ಜಿ ಆಗಿರ್ಬೋದು, ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ಸ್ ಇರ್ಬೋದು. ಈಗ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಹ್ಯಾಸ್ ಬಿನ್ ಡಾಮಿನೇಟಿಂಗ್ ಓವರ್ ಥರ್ಮಲ್ ಎನರ್ಜಿ. Then molecule has been changes their physical state from what? So gaseous to liquid to what? Finally solids. This yavaga. So what here? Okay. So intermolecular force. So dominating thermal energy. So thermal energy also that has to be exist among the molecules asте, because of that friction between the molecules. Okay, so thermal energy allige enagta hogutte molecules alli exist aguntadu. Okay, ಎರಡು molecules ನಡುವೆ ಏನಾದರೂ ಫ್ರಿಕ್ಷನ್ ಆಯಿತು ಅಂತ ಅಂದರೆ then that thermal energy has been formed. Okay, so ಯಾವಾಗ ನಿಮಗೆ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಥರ್ಮಲ್ ಎನರ್ಜಿನ ಡಾಮಿನೇಟ್ ಆಗಿರುತ್ತೋ ಅದು ಅಲ್ಲಿ ಆ್ಯಕ್ಚುಲ್ ಆಗಿ ಡಾಮಿನೆನ್ಸ್ನ ಎಕ್ಸಿಸ್ಟ್ ಮಾಡುತ್ತೆ. ದೆನ್ ಆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಹ್ಯಾಸ್ ಬೀನ್ ಚೇಂಜಸ್ ಫ್ರಮ್ ದ gaseous state to liquid state and liquid state to solid state. ಇದು ಒಂದು ಕಡೆ ಆಯಿತು ಅಂತ ಅಂದರೆ ಸಪೋಸ್ ಥರ್ಮಲ್ ಎನರ್ಜಿ is dominating over intermolecular force of attraction. Is dominating over here intermolecular force. Then that molecules or substance has been changes from solid to liquid. So liquid to gaseous. Okay, so the intermolecular force and as well as thermal energy which has been responsible for the here. Okay, so species which attain that here are specific physical state. Okay, probably one specific physical state ನಾವು ಅಟೈನ್ ಮಾಡ್ಕೊಂಡಿದೆ ಒಂದು ಸ್ಪೀಶೀಸ್ ಅಂತ ಅಂದರೆ ಬಿಕಾಸ್ ಈ ಎರಡು ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಡಾಮಿನೇಟ್ ಆಗಿದೆ. ಓಕೆ, ಸೊ ಇಷ್ಟು ನನಗೆ ಈ ಫೋರ್ಸ್ಗಳ ಬಗ್ಗೆ ನನಗೆ ಇನ್ಫಾರ್ಮೇಷನ್ಸ್ ಬೇಕಾಗುತ್ತೆ ವೈಲ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ದಿ ಸ್ಟೇಟ್ಸ್ ಆಫ್ ಮ್ಯಾಟರ್. Okay, so now let us go to that here some measurable property we must know. Okay, so measurable property with respect to gaseous species na so respective agi ಏನಾದರೂ measurable property ಯಾವುದಿದೆ? ಪ್ರೆಷರ್ ಇದೆ, Okay, mass is there, volume is there, temperature. So all these particular factor is there. No, these parameters are being what your measurable properties with respect to gaseous species. Okay, ಯಾವುದಾದ್ರು ಒಂದು ಸ್ಪೀಷೀಸ್ ಇರೋದು ಯಾವುದೋ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ gaseous ಸ್ಟೇಟ್ ಇದೆ ಅಂತ ಈಗ ನಾವು ಮೆಜರ್ ಮಾಡಬೇಕು. ವೆಯ್ಟ್ ಎಷ್ಟಿದೆ, ಅದಕ್ಕೆ ವಾಲ್ಯೂಮ್ ಏನಿದೆ, ಪ್ರೆಷರ್ ಏನಿದೆ, ಟೆಂಪ್ರೇಚರ್ ಏನಿದೆ, ಇದೆಲ್ಲ ಯಾವ್ಯಾವ ಫಾರ್ಮಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ, ವಿಚ್ ಇಸ್ ರಿಯಲಿ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್. ಇದು ಬೇಸಿಕ್ ಆದರೂ ಕೂಡ ಇದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಆಯಿತಾ. ಸೊ ಕರೆಕ್ಟಾಗಿ ಕೇಳಿಸ್ಕೊಳ್ತಾ ಹೋಗಿ ದಟ್ ಮೆಜರಬಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಗೇಷಿಯಸ್ ಸ್ಟೇಟ್. ಓಕೆ, ಸೊ ಆ್ಯಂಡ್ ನಿಮಗೆ ಒಂದು ಗೊತ್ತಿರಬೇಕು. ಸೊ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅಂತ ನನಗೆ ಗೊತ್ತಿರುತ್ತೆ. ಸೊ ಗ್ಯಾಸ್ ಆಗಿರ್ಬೋದು, ಸಾಲಿಡ್ ಆಗಿರ್ಬೋದು, ವಾಟರ್, ಸೊ ಐ ಮೀನ್ ಸೊ ಲಿಕ್ವಿಡ್ ಆಗಿರ್ಬೋದು. ಸೊ ಈಗ ಒಂದು ಪ್ರಾಬ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀವಿ ಅಂತ, ಗ್ಯಾಸಸ್ ಇಸ್ ಅನ್ಕಂಪ್ರೆಸಬಲ್. ಓಕೆ, ಲಿಕ್ವಿಡ್ ಅನ್ಕಂಪ್ರೆಸಬಲ್. ಓಕೆ, ಸೊ ಸಾಲಿಡ್ ಕೂಡ ಅನ್ಕಂಪ್ರೆಸಬಲ್ ಆಗುತ್ತೆ. ಓಕೆ, ಇಂಟರ್ಮಾಲಿಕಲ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇನ್ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ವೆರಿ ಹೈ. ಓಕೆ, ಸೊ ಲಿಕ್ವಿಡ್ಸ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಫಾರ್ಮಲ್ಲಿ ಇರುತ್ತೆ. ಗೇಷಿಯಸ್ ಸ್ಟೇಟಲ್ಲಿ ಸುನಿಲ್ ಅಂತಲೇ ಹೇಳ್ಬೋದು, ವೆರಿ ಸ್ಮಾಲ್ ಇಂಟರ್ಮಾಲಿಕಲ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್. ಓಕೆ, ಸೊ ಈ ಥರದ ನಮಗೆ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಯು ನೋ ದಟ್ ಹಿಯರ್. ಆ್ಯಂಡ್ ಶೇಪ್ ಅಂತ ಅಂದರೆ ಸೊ ಗೇಷಿಯಸ್ ಮಾಲಿಕ್ಯೂಲ್ ಡಸಂಟ್ ಹ್ಯಾವ್ ಎನಿ ಕೈಂಡ್ ಆಫ್ ಶೇಪ್ ಅದಕ್ಕೆ. ಸೊ ಲಿಕ್ವಿಡ್ ಕೂಡ ಅಷ್ಟೇ, ಅದಕ್ಕೆ ಯಾವ್ದು ತಗೊಳ್ತೀವೋ ಅದ್ರ ಶೇಪ್ ಎಕ್ಸಿಸ್ಟ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. ಆ್ಯಂಡ್ ಸಾಲಿಡ್ ಅಂತ ಅಂದರೆ ಇಟ್ ಹ್ಯಾಸ್ ಅ ಪ್ರಾಪರ್ ಶೇಪ್. ಓಕೆ, ಸೊ ಇವೆಲ್ಲ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಗೊತ್ತಿರುತ್ತೆ. ಬಟ್ ಅದಕ್ಕೆ ಮೀರಿದ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದೆ. ಇಸ್ ವಾಟ್ ಹಿಯರ್ ಮೆಜರಬಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ದ ಹಿಯರ್ gaseous state. So we'll do that particular concept, right? Okay, and which is really most important by the way. So please do focus on that. Okay, so ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡುವಾಗ ಅದು ಬೇಗ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ಇಟ್ಸ್ ವೆಲ್. ಸೊ let us talk about that here. So measurable properties of gases. Well guys, we would have your measurable properties and one cavity I can see that here mass. Okay, so and here pressure, volume and here temperature. So we have here the mass, pressure, volume and temperature. Okay, so let us go with it here very first. Now with respect to mass. So mass of the gaseous molecule ಹೇಗೆ ನಾವು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ. Okay, so the thing is that if you can see, so while taking up that concept, you just try to express that here. So mass of the gas in terms of gram. Okay, so ನಾವು grams ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡೋದು ಸೂಕ್ತವಾಗಿರುತ್ತೆ. Okay, so you just think over here. So mass of the gas ಅಂತಂದ್ರೆ of course you just consider here empty container. Okay, we have the here empty container. Their mass is being over here. Their mass is being here m. I must take here mass of this, that empty container is being here, so W1. Okay, and suppose if I fill this particular container with that here gas mix, so fill with gas, so then that container which has that so new weight. Okay, so let us say that W2. Then if you want to express that here, what is the mass of the gas? Okay, so therefore mass of the gas is being here. Mass of the gas which equals to here W2 minus W1. So which is in terms of and where that mass of the gas that has to be associated with the here one particular factor, what is number of moles. Okay, so where number of moles which is the here mass divided by here molecular mass. Okay, number of moles which equals to mass divided by molecular mass. Okay, suppose the number of moles of gas ಬೇಕು ಅಂತಂದ್ರೆ so we must know that here mass of the gas. Okay, and as of course that here molecular mass of the gas. Okay, so these two terms ಇಲ್ಲಿ ಬೇಕಾಗುತ್ತೆ. Okay, so mass ನಾವು ಅಲ್ಲಿ gas gaseous state respective ಆಗಿ gas ನ respective ಆಗಿ mass ನ ಹೇಳಬೇಕು ಅಂತ ಅಂದ್ರೆ so we will see we will have these particular things. ಅಂದ್ರೆ just express ಮಾಡುವಂತ ಒಂದು ವೇ ಗೊತ್ತಿದೆ ಅಷ್ಟೇ. So next we'll move the here the volume gas. So volume ನ ಹೇಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ let's see. And volume ಗೆ ಹೋಗಿ ನಾವು ಮುಂಚೆ so here two more factors you must know. Okay, suppose you just think of that the weight of 1 liter of gas. The weight of 1 liter of gas is called to be as the density of the gas. Okay, the weight of 1 liter of gas, what we call here? Okay, so density of the gas. Okay, and here the weight of 11.2 liter of gas. 11.2 liter of gas. You know what we can say that here? Vapor density of gas. Okay, so the weight of 1 liter of gas is being, you know what, density of the gas, and here the weight of the 11.2 liter of gas is being, you know what, vapor density. Vapor density. So whereas vapor density, which is independent on the temperature gauge. Okay, so which is independent on the temperature. Okay, so and more, one thing we must know that here. Okay, so mass does not depend on the mass of the gas. Mass of the gas does not depend on temperature. Mass of the gas does not depend on the temperature. So these mass thing you must know that here. Okay, so you must be so certain time okay, so mass of the gas does not depending on the temperature, where temperature does not depend on here mass of the substance. Okay, volume respective agi namage variations agutte. Okay, but mass ಮೇಲೆ temperature depend ಆಗೋದಿಲ್ಲ. Okay, so mass which is independent on the temperature. Okay. So this is, you know what, with respect to your mass days. So next we'll move on to the here. So another measurable property is, you know what, here volume of the gas. So of course here volume anta andre volume na we have a form express ಮಾಡಬಹುದು. Volume of the gas can be expressed in terms of here liter or in terms of ml or in terms of ml. Okay, so volume anta andre basically hege. So ಈಗ ವಾಲ್ಯೂಮ್ ಅಂತ ಅಂದ್ರೆ ಈಗ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಗೆ ಎಷ್ಟು ಅವೈಲೇಬಲ್ ಸ್ಪೇಸ್ ಸಿಗ್ತಾ ಇದೆ. ಓಕೆ, that gas molecule that would occupies that here available spaces, no, that we can call it as here volume of the gas. So one container alladu almost suppose if you can just see that. Okay, ಈಗ ಈ ಕಂಟೈನರ್ 1 ಲೀಟರ್ ಕಂಟೈನರ್ ಇದೆ ಅಂತ ಅಂದ್ರೆ ಓಕೆ, ಇವಾಗ ನೀವು ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ ತಗೊಳ್ತೀವಿ ಅಂದ್ರೆ ವಾಟ್ ವಿಲ್ ಬಿ ದ ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿ ಗ್ಯಾಸ್ 1 ಲೀಟರ್. ಅಂದ್ರೆ ಅವೈಲೇಬಲ್ ಸ್ಪೇಸಸ್ ಎಷ್ಟು ಸಿಗ್ತಾ ಇದೆ ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ ಅಷ್ಟು ಅದರ ವಾಲ್ಯೂಮ್ ಆಗಿದೆ. ದಟ್ಸ್ ಇಟ್. ಓಕೆ, ಸಪೋಸ್ ಇಫ್ ಐ ಟೇಕ್ ಹಿಯರ್ ಹೈಡ್ರೋಜನ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ನ ಫಿಲ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟೆ. ಓಕೆ, ಹೈಡ್ರೋಜನ್ ಮಾಲಿಕ್ಯೂಲ್ ಫಿಲ್ ಅಪ್ ಮಾಡ್ತೀನಿ ಅಂತ ಅಂದ್ರೆ ಈಗ ಈ ವಾಟ್ ಇಸ್ ದ ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ 1 liter. Okay, so just think of that. Suppose if I would take H2O2 plus N2. ಆ ಕಂಟೈನರ್ ಅಲ್ಲಿ 3 ಸ್ಪೀಷೀಸ್ ಇದೆ ಈಗ. Okay, and condition is that here those particular molecules are non-reacting species. ಹಾಗಾದ್ರೆ so what is the volume of the H2, what is the volume of the O2, what is the volume of the N2? 3 ಕೂಡ 1 ಲೀಟರ್ ತಾನೆ. ಓಕೆ, ಅಂದ್ರೆ ಇವಾಗ ಹೈಡ್ರೋಜನ್ ಇವಾಗ 3 ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ ಇದೆ ಅಂತ ಅಂದ್ರೆ ಸೊ 3 ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ನ ವಾಲ್ಯೂಮ್ ಒಂದು 1 ಲೀಟರ್ ಆಗಿದೆ. ಯಾಕಂದ್ರೆ ಆ 3 ಪರ್ಟಿಕ್ಯುಲರ್ ವಾಲ್ಯೂಮ್ಗೂ ಅಷ್ಟೇ ಸ್ಪೇಸಸ್ ಆಕ್ಯುಪೈ ಮಾಡ್ಕೊಳ್ತಾರೆ. ಅರ್ಥ ಆಗ್ತೀಯಾ? ಯಾವಾಗಲೂ ಇದು ಗೊತ್ತಿರಲಿ. ಸೊ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ಹಿಯರ್ ಸೊ ಆಕ್ಸಿಜನ್, ಹೈಡ್ರೋಜನ್, ನೈಟ್ರೋಜನ್, ಬಟ್ ದೇರ್ ಕಂಡೀಷನ್ ಇಸ್ ಟು ಬಿ ದೇ ಆರ್ ಆಕ್ಚುಲಿ ನಾನ್ ರಿಯಾಕ್ಟಿಂಗ್ ಸ್ಪೀಷೀಸ್. ಸೊ ನಾನ್ ರಿಯಾಕ್ಟಿಂಗ್ ಸ್ಪೀಷೀಸ್ ತಗೊಂಡ್ವಿ ಅಂತ ಅಂದ್ರೆ ಇವಾಗ ಇವನು ಹೈಡ್ರೋಜನ್ ಈ ಸ್ಪೇಸ್ ಎಲ್ಲ ನಂದೇ ಅಂತ ಅನ್ನೋ ಫೀಲಿಂಗ್ ಅಲ್ಲಿ ಇರ್ತಾನೆ. ಈ ಆಕ್ಸಿಜನ್ ಇವನು ನಂದೇ ಜಾಗ ಇರಲ್ಲ, ನಂದೇ ಈಗ ಅಷ್ಟು ಸ್ಪೇಸ್ ಕೂಡ ನಂದೇ ಅನ್ನೋ ಫೀಲಿಂಗ್ ಅಲ್ಲಿ ಇರ್ತಾನೆ. ಓಕೆ, ವಿಚ್ ಮೀನ್ಸ್ ದಟ್ ಹಿಯರ್ ಸೊ ಎಲ್ಲ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳು ಕೂಡ ಏನಾಗುತ್ತೆ ಸೊ ಸೇಮ್ ವಾಲ್ಯೂಮ್ನ ಆಕ್ಯುಪೈ ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ H2O2 N2 ಅಂತ ವಿಚ್ ಮೀನ್ಸ್ ದಟ್ ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿ ಗ್ಯಾಸ್ ಅಂತ ನಾವು ಹೇಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಓಕೆ, ದಟ್ ಸೊ ಯೂಶಲಿ ಅಲ್ಲಿ ಅವೈಲೇಬಲ್ ಸ್ಪೇಸ್ ಎಷ್ಟಿದೆ ಫಾರ್ ದ ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಷ್ಟು ಅದರ ವಾಲ್ಯೂಮ್ ಅಂತ ನಮಗೆ ಅರ್ಥ ಆಗ್ತಿದೆ. ಆ್ಯಂಡ್ ದಟ್ ಕ್ಯಾನ್ ಬಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಹಿಯರ್ ಲೀಟರ್ ಆ್ಯಂಡ್ ml. And one thing you must know that so volume of the gas can be expressed in terms of course here meter cube ಕೂಡ ಹೇಳ್ಬೋದಾಗುತ್ತೆ ನಾವು in terms of meter cube. But one thing you must know here, 1 meter cube which equals, you know what, here 1000 meter cubes. 1 meter cube which equals here 1000 liter. Okay, so or 1000 dm cube. Okay, so or 10 to the power of 6 ml or 10 to the power of 6 cm. Okay, so ಇಷ್ಟು ಫಾರ್ಮಲ್ಲಿ ಕೂಡ ನಾವು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಬೋದು ವಾಲ್ಯೂಮ್. Okay, so guys, having said that here, ಹಾಗಾದ್ರೆ ಈಗ ಈ ಒಂದು ಟರ್ಮ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ, ದಟ್ ಇಸ್ ನೋ ಮೋಲಾರ್ ವಾಲ್ಯೂಮ್. ಸೊ ವಾಟ್ ಈಸ್ ಆಕ್ಚುಲಿ ಮೀನ್ ಬೈ ಹಿಯರ್ ಮೋಲಾರ್ ವಾಲ್ಯೂಮ್? ಮೋಲಾರ್ ವಾಲ್ಯೂಮ್ The volume occupied by here 1 mole of a gas. Okay, so molar volume with respect to 1 mole alli navu helbekagutte. Okay, the volume occupied by 1 mole of a gas is called, you know what here, molar volume. So volume occupied by here, so 1 mole of a gas, and whereas here 1 mole of a gas only number of gas molecules is still Avogadro number. Okay, so number of gas molecules is being, you know what here, Avogadro. Okay, ಹಾಗಾದ್ರೆ ಈಗ molar volume ನ ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಗಿ if you can say that here, so molar volume, which means that, you know what, molar volume which is nothing but here, so 22.4 liter mix or 22,400 ml or 22,400 cm. Okay, so this could be that here molar volume of value is right? So as we know that here volume occupied by here, so 1 mole of a gas antare 1 mole of a gas is ಎಷ್ಟು number of particles irutte gas molecules, that is Avogadro number, and molar volume antare, you know what here, that is at STPL. Okay, at STP. Okay, so 22.4 liter. So where here temperature is being 273.15, where pressure is being here 180. So ಈ ಕಂಡೀಷನ್, so molar volume ಅಂತ ಅಂದ್ರೆ, so ಎಷ್ಟು ಲೀಟರ್ ಆಫ್ ವಾಲ್ಯೂಮ್ ಆಕ್ಯುಪೈ ಮಾಡ್ಕೊಂಡಿರೋ ಗ್ಯಾಸ್ is 22.4 liter. Okay. So this could be, you know, that another general properties of the gas is that is the volume. So next let us go to the here pressure here itself. Okay. So to focus here by the way guys. So pressure can be expressed by here in terms of P. Okay, by the way pressure antandre hege, how can we define it? Force per unit area, of course. So but the thing is that if you can see, okay, we have a container. Okay, so container has been there over and which has, you know what, gas molecule. Of course gas molecule antare they would have to be, you know, that their motion is being, you know, very random. Okay, ಅದು ಹೇಗೆ ಬೇಕು ಹಾಗೆ ಹೋಗುತ್ತೆ, random motion ಇರುತ್ತೆ, and ultimately it used to hit to the here wall of the container. Okay, ಯಾವುದಾದ್ರು ಫೋರ್ಸ್ ಅಲ್ಲಿ wall of the container hit ಮಾಡುತ್ತೆ, that force will be area, and a particular, you know, that a force in the ಎಷ್ಟು area cover ಮಾಡಿದೆ, that is, you know, area of, so area covered by your gas molecule. Okay, so that force by area what we call here pressure. Okay, so of course pressure ನಾವು ಯಾವುದಕ್ಕೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು in terms of, so pascal ಅಲ್ಲಿ ಹೇಳ್ಬೋದು. Okay, so bar ಅಲ್ಲಿ ಹೇಳ್ಬೋದು, bar ಅಲ್ಲ bar ಅಲ್ಲಿ ಹೇಳ್ಬೋದು, and atm ಅಲ್ಲಿ ಹೇಳ್ಬೋದು. Okay, so torr ಅಲ್ಲಿ ಹೇಳ್ಬೋದು, millimeter of mercury ಹೇಳ್ಬೋದು, centimeter of mercury ಹೇಳ್ಬೋದು, Newton per meter square. Okay, SI unit ಅದೇ ಅಲ್ವಾ pressure. So pressure the SI unit is being, you know what here, that is, so Newton per meter square. But ಹಾಗಾದ್ರೆ ಈ ಕನ್ವರ್ಷನ್ಸ್ ಅಲ್ಲಿ ನಮಗೆ ಬೇಕಾಗಿರೋದು ಏನು ಗೊತ್ತಾ? ಓಕೆ, ಈಗ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು 1 ATM ಅಂತ ಅಂದರೆ ಹೇಗೆ ನಾವು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಬೋದು? 1 atmosphere pressure. So 1.01325 into the power of 5 Pascal. Okay, or here I would say 1.325, so kilopascal. Okay, so here so we can say 760 millimeter of mercury. Okay, and so 76 torr. After 1 torr which equals to 1 millimeter of mercury. 1 torr which equals to 1 torr which equals to mm of Hg. Okay, so and here 76 centimeter of mercury, and okay, so 1.01325 bar. So these two forms are put up, we can express that here. So ಇಷ್ಟು ಪ್ರೆಷರ್ ಬಗ್ಗೆ ನಮಗೆ ಇನ್ಫಾರ್ಮೇಷನ್ ಸಿಗುತ್ತೆ. So then temperature is so another factor we have that here, another measurable property of a gas, that is what temperature. So the last measurable properties of gas is being what? That is temperature. So guys, temperature and how can we measure the real temperature with respect to what? So with respect, that is what, that average kinetic energy. Kinetic energy of the gas molecule of course directly proportional to absolute temperature. ಅದಲ್ವಾ, ಈಗ ಒಂದು ಗ್ಯಾಸ್ನ ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಗಿ ನಾವು ಟೆಂಪರೇಚರ್ ಹೇಳಬೇಕು ಅಂತಂದರೆ ಅದರ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿನ ನಮಗೆ ಗೊತ್ತಿರಬೇಕಾಗುತ್ತೆ. ಓಕೆನಾ? ಸೊ ಟೆಂಪರೇಚರ್ ಕ್ಯಾನ್ ಬಿ ಎಕ್ಸ್ಪ್ರೆಸ್ಡ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ದಟ್ ಹಿಯರ್ ವಾಟ್ ಆ್ಯಕ್ಚುಲಿ ಹೇಳಬೇಕು ಅಂತಂದರೆ ಟೆಂಪರೇಚರ್ನ ಹೇಗೆ ಮೆಜರ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ ಬೇಸ್ಡ್ ಆನ್ ದ್ಯಾಟ್ ಓಕೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಫ್ ದಿ ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್, kinetic energy of the gas molecules. Okay, and we can express in terms of either degree Celsius or Kelvin. So ಹಾಗಾದ್ರೆ here, so Kelvin ಅಂತ ಅಂದ್ರೆ of course what we can say that here. So in degree Celsius conversion ನಮಗೆ ಗೊತ್ತಿರೋದು ನಾವು okay, so plus 273. Okay, very simple thing we must know here. Okay, ಹಾಗಾದ್ರೆ here we must know another most important thing, that is absolute zero temperature. Okay, so absolute zero temperature here. Absolute zero temperature, that would be what here, minus 273 degrees Celsius. Okay, so absolute zero temperature ಅಂತಂದ್ರೆ ಯಾವಾಗಲಿರುತ್ತೆ, ಯಾವಾಗಲೂ minus 273 degrees Celsius ಅಥವಾ minus 273.15 degrees Celsius ಕೂಡ. ಓಕೆ, ನೋಡಿ ಹಾಗಾದ್ರೆ ಅಬ್ಸಲ್ಯೂಟ್ ಝೀರೋ ಟೆಂಪರೇಚರ್ ನೋಡಿ ಏನೇನೆಲ್ಲ ಆಗಿರ್ಬೋದು ಬಹುಶಃ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್. ಓಕೆ, ದ ಮಾಲಿಕ್ಯುಲರ್ ಮೋಷನ್ ಇನ್ ದ ಗ್ಯಾಸ್ ಹ್ಯಾಸ್ ಬೀನ್ ಸೀಸಸ್. ಓಕೆ, ಮಾಲಿಕ್ಯುಲರ್ ಮೋಷನ್ at zero temperature means okay, molecular motion in the gas ceases. ಅಂದ್ರೆ ಸ್ಟಾಪ್ ಆಗುತ್ತೆ. And volume of the gas becomes zero. Volume of the gas becomes zero. Pressure of the gas becomes zero. And kinetic energy of the gas molecules. Kinetic energy of the gas becomes zero. Okay, so at zero temperature, so these things gonna happen, guys. Okay, there is no molecular motion, the gas is being squeezes out. Okay, and here volume of the gas becomes also zero, and pressure of the gas becomes zero, and kinetic energy of the gas becomes zero at absolute zero temperature. Okay, so all these what here are most important measurable properties with respect to gaseous species. Okay, so here this is all about that here measurable properties. Now let us move on that here gas laws. Okay, so gas laws are really which are most important basically. Okay, so let us talk about here one by one. Okay, with respect to gaseous species, with respect to their corresponding mass, temperature, pressure and volume. Okay, we would have that here some gas laws. Okay, let us talk about here one by one. Okay, so please do focus. Gas classes. So guys, suppose if we can have that here, with respect to gas, we would have to know here mass basically, and pressure, temperature, volume. Okay, so this particular factor with respect to gases, so we must know here some sort of a gas classes. Okay, ಅಂದ್ರೆ ಇವಾಗ ಇಷ್ಟು ಪ್ಯಾರಾಮೀಟರ್ನ ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಗಿ ನಾವು ಒಂದು ಗೇಷಿಯಸ್ ಸ್ಪೀಷೀಸ್ಗೆ ಏನಾದರೂ ಹೇಳ್ತಾ ಹೋಗ್ತಾ ಇದೀವಿ ಅಂತ ಒಂದು ಲಾಸ್ಟ್ ಪ್ರಿಡಿಕ್ಷನ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ ಅಂದರೆ ಅಷ್ಟು ಲಾಸ್ಟ್ ಪ್ರಿಡಿಕ್ಷನ್ ಮಾಡಲಿಕ್ಕೆ ನನಗೆ ಒಂದಷ್ಟು ಎಮಿಟರ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದೆ, ವಾಟ್ ಇಸ್ ಗ್ಯಾಸ್ ಕ್ಲಾಸ್. ಸೊ ಈಗ ಅಷ್ಟು ಪರ್ಟಿಕ್ಯುಲರ್ ಟರ್ಮಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ, ಇನ್ಯಾವುದು ವೇರಿ ಆಗ್ತಾ ಇರುತ್ತೆ, ಇನ್ನೊಂದು ಯಾವುದು ವೇರಿ ಆಗಿರುತ್ತೆ, ಇನ್ನೊಂದು ಲಿಕ್ವಿಡ್ ಪ್ಯಾಟರ್ಗಳು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗ್ತಾ ಇರೋದು. So like this, so based on this particular scenario, we will have it like gas class. Okay, very first, let us go to that here. Okay, so Boyle's law. Boyle's law. Okay. So Boyle's law, what it actually says that? So here in the okay, at constant temperature, the volume of the given mass of a gas. That word which is most important. So that mass of a gas is constant ಆಗಿರುತ್ತೆ. That you must know that here. So you know that at constant temperature, the volume of the given mass of a gas, gas is inversely proportional to volume. Pressure. Inversely proportional to your pressure. So this could be, you know what your Boyle's law states that here. So at constant temperature, the pressure or volume of the given mass of a gas, which is inversely proportional to the shear volume, Okay, so where we could see that the proportionality symbol has been replaced by one constant, and that is K. Okay, hence we can write that here equation becomes P which equals to K by V. Okay, or so PV which equals to K, that is another particular equation where that PV is become, suppose if their ratio is being fixed means, okay, so then the equation becomes P1 V1 which equals to P2 V2. That is also another form of, okay, so Boyle's law. Okay, this could be, we can write it as that. So this is all about that, mathematical expressions regarding the Boyle's law. So where Boyle's law says that here at constant temperature, the pressure or volume of the given mass of a gas is mostly proportional to the pressure. So the vice versa formula of the okay, and equations not super focus on. And here you know what, graphical representation is most important, right? Okay, so graphical representation anta nಮಗೆ so ಈ ಫಾರ್ಮ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು, ಈ ಫಾರ್ಮ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು. ಅರ್ಥಾತ್ so logarithm form ಅಲ್ಲಿ ಕೂಡ ಎಕ್ಸ್ಪ್ರೆಸ್. So ನೋಡಿ, so we have that here many graphical representation with respect to these kind of equations here. Okay, so let us go with that. So well guys, if you can see that here, suppose pressure versus 1 by V is by plot. Okay, so pressure versus 1 by V, we must know that here P which equals to K into 1 by V, that would resembles that here y is equal to mx plus, where slope is nothing but here K. Okay, so where x axis 1 by V ತಗೊಂಡಿದ್ದೀವಿ, y axis ಅಲ್ಲಿ pressure ತಗೊಂಡಿದ್ದೀವಿ. So of course what we would expect here, right? Straight line. So but at constant temperature, suppose this is with respect to T1 and temperature. So this is T2. So this could be here T2. Okay, so what I must write right now. So where T3 that has to be greater than T2 and T1, equation ಬರೀಬೋದಾ? Okay. So T3 greater than T2 greater than T1. Okay, so you just focus this equation, okay? P which equals to K into V. Okay, so here we know ideal gas equation is PV which equals to nRT. Okay, so where in this particular case T is constant, right now R is become constant and number of moles. Now ಮುಂಚೆನೇ ಹೇಳಿದೀವಿ ಇಲ್ಲಿ volume of the given mass of a gas ಅಂತ. So okay, that is also N is also is being constant here. So P which equals to nRT divided by 1 by V. ಹೌದಾ? ಹಾಗಾದ್ರೆ ಈಗ nRT that is nothing but what here K ಅಂತ ಹೇಳ್ಬೋದಲ್ವಾ? Okay, so here K which equals to nRT ಅಂತ ಅಂದ್ರೆ, so as slope increases temperature is also increases. K ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆಗ್ತಿದೆ ಅಂತ ಅಂದ್ರೆ ಸೊ ಟೆಂಪರೇಚರ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ ಅಲ್ವಾ? ಹಾಗಾದ್ರೆ ಎಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಲ್ಲಿ ಸ್ಲೋಪ್ ಜಾಸ್ತಿ ಇರುತ್ತಾ? ಸೊ ಹಾಗಾದ್ರೆ ಈ ಈಕ್ವೇಷನ್ ಬರೀಬೋದಲ್ವ ನಾವು? ಸೊ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಅರೇಂಜ್ಮೆಂಟ್ ಬರೀಬೋದಲ್ಲ, T3 greater than T1, so T3 greater than T2 greater than T1. Okay, so ಇದು ನಮಗೆ ಈ ಕರೆಕ್ಟ್ ಫಾರ್ಮ್ ಕರೆಕ್ಟ್ ಇದೆ. ಆರ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಹಿಯರ್ T1 T2 ಓಕೆನಾ? ಸೊ ಇದು ಈ ಪ್ಯಾಟರ್ನ್ ಗೊತ್ತಿರಲಿಲ್ಲ. So T3 T2 greater than T1. Okay, so this is with respect to what here. Okay. So P which equals to K into 1 by V form of the graphical representation. Okay, so then you just go with that here. So this equation P which equals to K. So as we know that here, so with respect to statement, if I write that, if I plot a graph, so pressure versus volume. So whereas that here pressure versus volume on the other, so where pressure increases, volume has been decreases. So volume decreases, of course here just think of it. Okay, so rectangular hyperbola has been. This D1 at D2 under constant temperature. Okay, and that graphical form is being what here hyperbola. Hyperbola, but at constant temperature we have. So we are plotting a graph at constant temperature, isotherm. Okay, so this representation, you know what here, that is isothermal. It seems that temperature is being constant. Okay, so the graphical representation, what they call here, isothermal. So here you just think of that. Okay, as pressure increases here, volume that has been increases, but I would take here point here A. And I will take here point here B. Okay, so how will we get a temperature number in there? So what your opinion regarding this is the temperature. So TA suppose greater than TP na, but TB greater than TA na, or TA which equals to TB. So what is your opinion here at two different points? TA which equals to why? Temperature is being constant. So temperature constant ಇರೋದ್ರಿಂದ ನಿಮಗೆ ಯಾವುದೇ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಟೆಂಪರೇಚರ್ ವೇರಿ ಆಗ್ತಾ ಹೋಗಲ್ಲ. Temperature is must be constant. Okay, so here ಈಗ ನಾನು ಈ ಪಾಯಿಂಟ್ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಟೆಂಪರೇಚರ್, ಈ ಪಾಯಿಂಟ್ ಟೆಂಪರೇಚರ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಈ ಪಾಯಿಂಟ್ ಟೆಂಪರೇಚರ್ ಹೇಳ್ತಾ ಇದ್ರೆ ಇಸ್ ಮಸ್ಟ್ ಬಿ ಕಾನ್ಸ್ಟೆಂಟ್. Okay, must be same. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? So this is the thing we have to know while taking up here graphical representation. Okay, graphical representation ಮಾಡುವಾಗ ಈ particular forms ಗೊತ್ತಿರಬೇಕು. Okay, and one thing we must know that, okay, so at high pressure, okay, gas molecules that would violate your Boyle's law. Okay, at the high pressure, so gaseous molecules violates pressure. So however, what is the criteria for gas molecules to obey here Boyle's law? At low pressure and high temperature. Low pressure and high temperature. Low pressure and high temperature, that will be criteria for that here. So Boyle's law na exist ಮಾಡಬೇಕು, obey ಮಾಡಬೇಕು gas molecules ಅಂತ ಅಂದ್ರೆ. So low pressure and gas law ಅಂದ್ರೆ high temperature is being, okay. Okay, now, so well guys, suppose you just take here this equation. Okay, so P which equals to K into 1 by V and PV which equals to K. ಇವಾಗ ಈ ಎರಡು ಪರ್ಟಿಕ್ಯುಲರ್ ಇಕ್ವೇಷನ್ಸ್ ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಸೊ ಗ್ರಾಫಿಕಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡುವಾಗ ಯಾವ್ದು ನಿಮಗೆ ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ಸಿಗುತ್ತೆ, ಯಾವ್ದು ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ಫಾರ್ಮೇಷನ್ ಮಾಡೋದು. ಓಕೆ, ಸೊ ವೇರ್ ಪಾಸಿಟಿವ್ ಅಂಡ್ ಆಸ್ ಪಾಸಿಟಿವ್ ಅಂಡ್ ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ವಿಲ್ ಲುಕ್ ಔಟ್ ದೇರ್. ಸೊ ಬೈ ದ ವೇ which law is this? Boyle's law. So Boyle's law ನಲ್ಲಿ pressure is constant, right? ಹಾಗಾದ್ರೆ pressure directly proportional to volume, right? अभी ऊपर है ना. So K into 1 by V. Suppose if you can apply logarithm on both sides. Okay, log P, log K plus log 1 by V. Okay, suppose if you can plot that here graph in between that here log P versus log V. Okay. Log 1 by V. So of course we are going to get here a straight line. So since you know what y is equal to mx plus c. So where x-axis we can take here log 1 by v. Okay now, and so where m can be, you know what here, that slope is being here 1. Okay, and constant is log k is being constant. That is log k intercept. Okay, so log k is being intercepted. Okay, and slope, of course, you would get here. And yaake nಮಗೆ ಇಲ್ಲಿ straight line ಬರುತ್ತೆ because here no log p and log k their power is being what same. Power is being here 1. Okay, hence we got here over here a straight line. Okay, and if you can see that theta supposed to be here, slope is being 1 and theta is just the angle 45 degree. Okay, so and here tan 45 degrees is being what? What? Tan 45 degrees being here what? Okay, so this we must know. Okay, and e formal of graphical representation ಬೇಕಾಗುತ್ತೆ with respect to points. So let us take here another equation. So where PV which equals to K. So again apply here log. Okay. So what we can see that here log P plus log P which equals to here log K and log P which equals to log K minus log P. Again you plot the here graph between log P versus log P. Log P is log 1 by d. So what you could get here? Negative. Okay, so negative formula I mean that so decremental formula 1 log P. And here of course slope and intercept of course here log K, whereas that here slope is being log P. Okay, slope is being here -1. Slope is being here -1. Why? Because here minus is here, okay, and intercept is being here log K. So guys, another you can see that here graphical representation in between that here product of pressure, volume versus speed and product of pressure, volume versus speed. Okay, so how we could get that here graph here means, okay, suppose pressure you can take and here speed. Okay, we would get here straight lines. We would get here straight line. Why? Because when pressure increase ಮಾಡ್ತಿದ್ಯಾ ಅಂತ ಅಂದ್ರೆ ಇದರ ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಅಂಡ್ ಆಫ್ ಕೋರ್ಸ್ ಅಟ್ ದ ಸೇಮ್ ಟೈಮ್ ಪ್ರೆಷರ್ ಕೂಡ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಓಕೆ, ಅದು ನಿಮಗೆ ಪಿ ವಿ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಪ್ರೆಷರ್ ಅಂಡ್ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ಏನು ಅಫೆಕ್ಟ್ ಆಗೋದೇ ಇಲ್ಲ ಆ ಟೈಮಲ್ಲಿ. ಓಕೆ, ಒಂದು ಫ್ಯಾಕ್ಟರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ, ಇನ್ನೊಂದರಲ್ಲಿ ಈ ಕಡೆ ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಅಟ್ ದ ಸೇಮ್ ಟೈಮ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಮೀನ್ಸ್ ಪ್ರೆಷರ್ ಅಂಡ್ ವಾಲ್ಯೂಮ್ ಬಿಕಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಾ ಅಲ್ವಾ? ಸೊ ಹಾಗಾಗಿ ದಟ್ ಇನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೇಸ್ ವಾಟ್ ವಿ ಗೆಟ್ ಹಿಯರ್. Okay, so that line will get here, that line that has been parallel with the x-axis. Okay, suppose in the same way if you can take product of pressure and volume versus here volume, of course again you get here. Okay, so in case alli namage so pressure and volume is become here, the product has become constant. Okay, this graphical representation namage boys na respectively godagutte. ಗೊತ್ತಾಗ್ತಿದೆಯಲ್ಲ? ಕ್ಲಿಯರ್ ಆಯಿತು? ಐ ಶ್ಯೂರ್ ಗೈಡ್. ಓಕೆ ಅಣ್ಣ, ಇದರ ಮುಗಿದ ಕ್ಲಾಸು.